Video should be ready to be embedded in the web page. Hello, hello. So we have our chair for the session. We are still missing 2 of the presenters. It should be on.
Okay.
I have here all the videos, so I can broadcast from here, which is the same source as the Zoom feed, so probably the quality gets a bit better. And so you can, after we start, you can just introduce the paper. I send the video, and then we have time for the question and answer after each video. If we are still quite early.
Okay, we wait for the other speaker, probably. We still have 10 minutes.
And we normally wait like 5 after the scheduled time to have people jump in. But they generally connect at a reasonable hour, not too late.
Non si sente? Eh?
Sì, si sente, Fabio.
Scusa.
Before to start, so we have any chat to collect the question for the audience.
We have the question may come through the chat here in Zoom or through the VUVA, the chat on the VUVA channel.
Okay, so we open the chat with Zoom.
We normally try to keep an eye on it, and if someone posts a question, we normally relay to the chat or vice versa.
Okay, fine.
Ideally, we should have turned off the chat on Zoom to have all the people do their stuff on the chat on VUVA, but then it was too dangerous because sometimes when connection get messed up, then the microphone doesn't work. So it's always good to have also the chat here in Zoom.
Okay.
Anyway, I think it worked quite well up to now, this method. I mean, we didn't have crash in Zoom, and the embedding in VUVA works reasonably well for a pure attendee. If you are a speaker, of course, it works much better if you connect through Zoom as an external tool. But in the end, it worked.
I guess everybody is used now to virtual conferences, so technologies are well
Yeah,
quite used for.
but still the integration of different platform is still sometimes complicated. So apparently, before a change in Zoom, you could do everything from the embedded version, and that would have been easier to some extent for some of the attendee. But now they also recommend, okay, you need to be a panelist, much better if you use the standalone Zoom application. Even though it works also if you're using the embedded one. Okay, I'll check messages and see if people are coming. At the moment, we're still lacking half of the people and spectators. But okay, let's wait.
Okay, we'll wait 5 minutes.
Yep.
I was trying to show my 3D in a cool HTML. Turned out was not that easy. It didn't work so well. So I tried browsing around. For an answer took so long. Till I found this orange website where I heard singing this song. WEB3D is the place to be. Here your scene will not freeze, it will show like a breeze. You'll see WEB3D. You can join for free. Thanks Chronos and Ivy, and you can log in and then leave. WEB3D is in Italy, with the sole and the mare, the best of mangiare virtually. Don't be mad, don't cry and be sad. You will follow our rants, dress code underpants. Now picture that at WEB3D. It's so fun to be, and the social event takes you a tower that's bent. You see WEB3D is in Italy. I hope
I see that we are still missing one author, so we'll wait for a couple of minutes before start.
Yes, one of the author of the second paper
Yes.
sent a message that it was had a problem to join today. Another author of the same paper should have joined, but I don't see him online yet. So in case we can just broadcast the video without a question and answer later on.
Fine. Well, I think we can start. Okay. So, hi everybody again. Welcome to this paper session on WEB3D 2021. And here we have three interesting papers. First one, supporting web-based collaboration for construction site monitoring. Second one, WEB3D, an open and customizable platform for visualizing and analyzing cultural heritage artifacts. And the last one, how long do you want to maintain these things? Understanding the challenges faced by WebXR creators. So we start with the first paper. The speaker is Andreas Dietsky from the Fulda University of Applied Sciences. And okay, we can start.
Hello to everyone. Hello and welcome to our presentation with the title Supporting Web-Based Collaboration for Construction Site Monitoring. My name is Andreas Dietze and I'm a PhD student from Fulda University in Hessen, Germany. My research fields are computer graphics, extended reality, computer vision, and web technology. The presentation agenda consists of a short introduction into digital construction site monitoring, including a demo video of our system and an overview about the state of the art and our system pipeline. Followed by this, the difference detection, the representation of these differences, the web-based collaboration, and a conclusion are addressed. So the background is to deal with the problem that the coordination and monitoring of construction sites is very complex and time-consuming. This leads to the problem that errors or deviations from the planning data are discovered often too late, which can result in high follow-up costs or endangers adherence to the schedule. And this is where digital construction site monitoring using augmented reality can be very useful. First, it is still an open research topic due to the constant improvements and enhancements in augmented and mixed reality technology, and measurements of the air's build state in form of a 3D reconstruction can be used to detect errors or deviations at an early stage by a comparison with the planning data. Identified errors or deviations can also be used to update the planning data if they are within tolerance, which allows a synchronization between the planning and measurement data. This also involves modernizations or redesigns of existing buildings, like the installation of new doors or the sealing of old ones. Finally, deviations can be visualized on several clients, which provides a collaboration between all stakeholders to support decision-making processes, and in this regard we made a little demo video. First, the data acquisition by a 3D reconstruction is done for a comparison with the planning data. Once the comparison is done, the differences are represented in form of an augmented reality visualization and a system-independent web-based representation, which is shown here on top of the augmented reality visualization. Next to the web-based representation, a live view from the HoloLens is sent to the connected web clients. Unfortunately, when simultaneously recording with the native device portal, a second camera stream from the webcam doesn't work, so the live frame is restricted to the AR rendering. To mark the differences of interest, the differences can be selected in the AR and web client and are highlighted between all collected clients to the backend. As related work, for example, Dobos et al. Is to mention, who described a method that recognizes differences between 3D models in the screen space and visualizes them for the user. To determine differences, various data like color, depth, normals, and texture coordinates are compared within the screen space to determine whether there are changes and what kind of changes are involved. Also to mention is Tudas et al., whose approach compares point clouds from real scenes with planning data in order to enable an automated building documentation. The point clouds are recorded using photogrammetry and structure from motion. For the comparison, the recorded point cloud and the planning data model are inserted into a voxel grid to decide whether there are any deviations between the data based on the distance between the points and the model. An unified XR content representation and cross-environment rendering method for the web is introduced in Lee et al., which uses an HTML extension that provides text for creating XR content that is displayed in the browser. In Grandi et al., a comparison of collaborative 3D tasks between a symmetric VR-VR, a symmetric AR-AR, and one asymmetric VR-AR collaborative environment is presented. The evaluation showed that a collaboration in the symmetrical VR environment outperforms the other symmetric AR environment as well as slightly the asymmetric VR-AR environment due to the more intuitive interaction with the VR controllers. A web-based mixed reality tool for construction planning and supervision is presented in Etzold et al. Here, a use case is described how people from different devices at different locations can use the tool for collaborative aspects by supporting a shared view of the current state of a construction project using photo collections. So, to provide an overview of how our system works, we made an overview which illustrates the whole system pipeline. On the left side, the 3D planning data and measurement data in form of a 3D reconstruction is shown, which are used for the comparison. Once the comparison is done and the 3D planning data has been updated based on the detected differences, the system provides a web-based and system-independent representation of the results using the XFreedom framework, as illustrated in the middle. This visualization consists of the used datasets, which are the original planning data, the updated planning data, and an overlay of them. Within the main view, these states can be toggled, and additionally, the respective wireframe and the detected differences are visualized. Next to the render area on the right side of the figure, a numeric and interactable representation of the differences is shown. For example, if a specific field within the table is selected, the associated rendered difference also will be highlighted. In the bottom right corner, an augmented reality visualization of the measurement data and differences is illustrated, which can be also streamed to the web front end, and within the next slides we will take a deeper look how the individual steps are done. So next we take a look at the comparison between the measurement and the planning data and how the differences are determined and used to perform an error correction by updating the planning data based on the detected differences. In case of planning data acquisition, a 3D model of the planning data is either available or can be extruded from the ground plan's outline using a specific tool for this purpose in our system, or by using third-party software like Blender or Photoshop. The measurement data can be obtained either by a model-based approach like Microsoft HoloLens does. Model-based in this case means that the 3D reconstruction results in a complete 3D cut model instead of a raw point cloud, or it also could be used the raw point cloud data. In case of the planning data segmentation, the 2D ground plan is used and converted into a point cloud. The segmentation is done by use of a Euclidean cluster extraction, which results in one ground segment and a cluster of wall segments, as illustrated at the bottom. Based on the extracted wall cluster, we are also able to locate and measure window and door objects by finding the both nearest neighbors of each wall segment, which are connected by blue lines within the figure at the bottom. In addition, this provides adjacency information for the wall, window and door objects. Furthermore, a segmentation and extraction based on the ground plan point cloud also provides the location of a segmented object in 3D space. The location and length of the found elements in the planning data are the base for the later comparison with segmented elements from the measurement data. The figure on the right shows the overlay of the extracted elements from the planning data within the point cloud of the measurement data. For the segmentation of measurement data, the point cloud is first cleaned up by removing outliers that are not part of the room. Based on an orthographic projection of the point cloud along the respective coordinate plane xy, xz or yz, a mass histogram is created as shown on the left. In the next step, outliers are identified by the first and second amplitude in the mass histogram and are subsequently removed, or better said cut off, before the first and after the second amplitude. This technique also enables a segmentation of entire wall sides, which are used to identify door or window elements within the actual data. The localization and segmentation of window and door elements within the actual data is performed out using alpha shapes, which are primarily used to extract the concave hull of a planar point cloud, but also can be used to find openings in a planar point cloud, as shown in the figure at the bottom. An overlay of all extracted objects from the planning and measurement data, including the ground plan, is visualized in the bottom right. To update the 3D planning data based on the detected differences, vertices which are relevant for a manipulation have to be located. This is achieved within 4 steps based on an overlay of the 3D planning data point cloud and the point cloud of the ground plan as shown in the bottom left. First, rectangular intersection shapes are set up at a connection point of a window or door object to its correlated wall segment, and secondly, vertices of the original 3D planning data are located within the intersection shapes. Green intersection shapes belong to a start point of a window or door, and the green vertices detected within belongs to a wall connected to that window or door. The same it is for the red intersection shapes and vertices, but they belong to an endpoint of a window or door object. Purple vertices are not relevant for a manipulation. Based on the width difference of the extracted objects from the planning and measurement data, which we can see in the right table, all detected vertices next to a start or an endpoint are manipulated based on the determined deviations on this side respectively. Finally, the updated cut file is saved persistently and can be visualized using an application-dependent visualization which has no annotation or other informations about the differences. Okay, so we now have our differences detected and updated the 3D planning data based on them. And in the next part, we take a look at the representation of the differences, which consists of a web-based difference representation and an augmented reality difference visualization. When exporting the updated planning data, the system also creates a web frontend for a system-independent presentation of the difference detection result using the XFreedom framework for the rendering. The result page consists of several views, which are used for the individual datasets. Within the first view of the area marked with 1, the original 3D planning data is visualized. The view marked with 2 consists of the updated planning data, and next to it, marked with 3, the updated planning data is rendered on top of the original planning data. Below the top area, the main view marked with 4 is located. Within it, the different datasets can be rendered separately, and it offers several other features, like rendering also the wireframe or only the differences which are interactable. This means that an interaction with a 3D difference within the main view or the respective table element marked with 5 representing this difference will highlight the 3D element as well as the table item and vice versa. When connected to the backend, it is also possible to get a live view from the person's view at the construction site using the HoloLens, which is marked with 7 and embedded in the user interface marked with 6 to control the main view. As mentioned, the displayed data within the main view can be toggled. In addition, when also rendering the 3D element representing the determined difference, this annotates whether this difference is an extension, which is the case if a difference is visible when rendering the original planning data, or a reduction if the difference is visible and the updated planning data is rendered. It is also possible to render the point cloud used for the difference detection, including the wireframe of the original or updated planning data and the differences, so all visible elements can be rendered separately or together in all variations. The total differences and differences of the respective wall sites are also represented in form of a table. Both the table elements and the corresponding 3D differences are interactable, so an interaction with a table element highlights the 3D difference and vice versa, as shown on the right and at the bottom. Besides the visualization of differences using augmented reality, our augmented reality frontend offers several other services. First, there is the measurement data acquisition to mention, and the acquired data can be saved locally on the device or can be sent to the backend. Determined differences can be visualized and are also interactable, which allows a selection of the difference of interest. This information, as well as a live stream from the augmented reality frontend, can then be shared via the backend to all other connected web frontends. The next part of this presentation consists of the use of our proposed system in terms of a web-based collaboration and is divided into our collaborative environment, some use cases, and details about how the web service and the communication between all clients work. Our collaborative environment consists of the HoloLens AR frontend, the web frontend using XFreedom, and a Node.js backend which provides the difference detection as a web service in form of a Node.js module. Based on the service, which the environment currently offers, we implemented 3 use cases. Within the first use case, the user is using existing data from the database or uploads new data to the backend and triggers the web service by a web frontend. The system then performs the difference detection and sends the result page back to the user. This, for example, is especially useful for a remote user at home or at an office, like an engineer or project owner, and due to its web-based difference representation, it can be used on any device. In the second use case, the user is physically on the construction site and uses the AR frontend, first to capture new measurement data, and secondly, to visualize the result from the difference detection performed by the web service in form of an augmentation. The third use case combines both front ends to allow a collaboration using the different front ends. For example, user A is at the construction site using the AR front end, and user B and C are connected to the backend by web front ends. Instead of using pre-scanned measurement data from the database, the currently captured data from user A can be also used. In addition, the AR front end is able to stream a live view from user A to the connected web clients. Determined differences are visualized within our front ends, and any interaction with a certain difference will be highlighted within the other front ends. So technically seen, the difference detection web service is a C++ Node.js server add-on, which allows the use of native C++ applications as a web service. For the communication between the backend and our clients, we used a REST API and WebSockets. The REST API is primarily used for the data exchange of the planning and measuring data when, for example, uploading newly acquired measurement data to the backend or to get pre-recorded data from the backend. The result of the difference detection is also provided via the REST API. In case of the AR frontend using newly acquired measurement data, the difference detection result consists of JSON data, which provides the position and dimensions of the detected differences based on the existing AR session. For the web frontends, the result exists in form of a newly created HTML file containing the difference detection result. All interactions in form of selecting differences of interest are transmitted by WebSocket, as well as the video stream from the HoloLens is first sent to the backend and then broadcasted to all connected web frontends. The last part of the presentation consists of a conclusion, which is divided into a summary and the future work. To summarize, we described a system to support web-based construction site monitoring by automatically detect differences between a 3D reconstruction and the corresponding planning data. In addition, the original 3D planning data cut can be updated based on the detected differences if the differences are within tolerance or cannot be corrected. This also involves modernizations or redesigns if, for example, new doors are set or old ones are seed, as illustrated within the pictures at the bottom. Left, we can see that the original model has 5 openings, but the updated cut on the right only has 3. This is because the 2 doors were sealed as part of a redesign, and thus the updated 3D planning data represents the real state of the room. The difference detection is provided as standalone C++ application and as a web service via a Node.js server add-on. To allow a collaboration between all stakeholders to support decision-making processes, in case of a detected difference, a system-independent and web-based representation of the differences using XFreedom, as well as a AR front-end for the data acquisition and visualization of detected difference was presented, which allows a cross-device interaction and also a video stream from the AR front-end to the web front-end. Concerning the future work, the height differences are determined but are not yet included in the planning data update. All in all, the prototype is subject to constant further development, and further next steps have to have a focus on more complex geometries, since in the actual state it is limited to cuboid building interiors. Another aspect is the integration of our tool to support creating 3D planning data based on the 2D ground plan into our system pipeline as a web service. Here, also a UI which supports a manipulation of the ground plan could be addressed. Also, a support of other AR devices like AR-capable phones and tablets is to mention, which also includes an update from our HoloLens 1 AR front-end to the HoloLens 2. In terms of a difference representation, we want to achieve a more meaningful visualization depending on the respective front-end, especially the AR front-end, which, for example, includes a transmission of the position and orientation from the AR front-end camera to the web front-end. Another subject is a better annotation of differences, for example, if they are too long or too short. At least, the extension of the web frontend by an UI to control the whole pipeline is on our agenda. So, thanks for your attention. Any questions?
Thank you to the author. It's an interesting talk. And okay, now I have a question for attenders or from the online chat. If you have something, I can check here. Chat, nothing good. If you don't have question, I have a question eventually, if I can, okay. So as I said, it's a very hot topic, both research and industrial applications. But my question is that the blueprint layout is usually quite different from the point cloud of a real world indoor scene. Okay, since I guess we have a lot of clutter from objects, parameters. I saw a lot of occlusions in your reconstruction, and from the clutter and the structure itself sometimes. Okay, and how do you deal with the occlusion and clutter, and how the 3D reconstruction is accurate?
Yes, in terms of the planning data and 3D point cloud, yes, there are for sure not exactly the same. This is obvious. But in terms you have a ground plan often. So this is what you in most any cases have from the building, and by providing the planning data directly from the floor plan, there is a little difference also in this type of manner. And mostly we use the ground plan for the segmentation, as we saw in the video, and it also offers for the visualization. And the second term of your question, sorry,
Okay, so okay, yeah, I guess so. You have a segmentation module in some way in order to separate structural part, permanent structural part from the objects and clutter and so on, that I guess are not represented in your blueprints. So okay, so you have also a segmentation step. Okay,
yes,
in order to figure out layers and also okay,
yes,
objects and more. Okay.
yes, and
Okay.
you also mentioned occlusion.
Occlusion,
Yes,
yeah, even self-occlusion. Okay.
Yes, yes. We also have a little technique for occlusion or high specular surfaces, for example, and they often cause problems during the reconstruction. And we have a little tool to mark these areas, and they are also included in the cleanup process.
Okay.
It's a real big pipeline, and it's all fitting not in one paper. So we addressed the deeper details, how, for example, we managed occluded objects is in the related work we also included in the paper. So
Okay.
depending on our earlier work. So there's a deeper focus on the how the difference detection and all that stuff is done.
Okay, fine. Thank you. Thank you for your answer. And then you have other question from audience, online audience?
There was a question down in the chat, but one of the authors already started answering on the chat.
Yes.
You can maybe elaborate.
Okay, or chat. No, here I don't. Okay, yes. Okay, I'm reading, but okay. Question is from the audience. Can this be used for external construction sites, such as electrical charging station, for example?
Yes, as mentioned in the chat, the hardware from the HoloLens mostly is not yet capable to handle such big dimensions, but you can reconstruct it part-wise, for example. If I understand the question right.
Okay, I also see there is the reply on the chat itself. Okay, so it's a hardware problem, still an hardware problem. Okay, so it's for outdoors and more. Okay. Fine. Okay. Thank you again, Trias.
Thank you.
And then we can go to the next paper. The second paper. I see that the author. There is the speaker for the second paper. No.
Yes, just pop in. I will promote it as a member. But in the meantime, we can send the video.
Okay.
I just logged in.
Welcome.
We should come online soon, and I will send the video.
Hi. Hello.
Hi, hello.
Hello.
On WEB3D, an open source. Welcome, and thank you for attending our presentation on WEB3D, an open source platform for visualizing and analyzing cultural heritage artifacts. First, I'd like to introduce you to my fellow presenters. Yuhao Zhu, Assistant Professor of Computer Science at the University of Rochester. Josh Romph, Lead Software Engineer of the Digital Scholarship Lab at the University of Rochester. Elias Newman-Donahue, Software Engineer and Student in Computer Science and History. Famous Clark, Software Engineer and Student in Computer Science. And Mohammed El Sayed, Software Engineer and Student in Electrical and Computer Engineering and in History. Lastly, I'm Gregory Hayworth. I'm Associate Professor of English at the University of Rochester, and I direct the Lazarus Project, which is an initiative to recover cultural heritage objects using a variety of imaging techniques. One of the things that I'd like to talk to you today about is the problems facing humanities researchers and teachers into cultural heritage. This field faces a series of obstacles, whether they be ancient manuscripts, paintings, or artifacts. These cultural heritage objects are often very difficult to work with or teach about because they're complicated, they're detailed, often they're damaged, and they're just generally hard to study in a nuanced way. Over the past decade, researchers and scientists have increasingly been turning to 2D and 3D imaging techniques, such as multispectral or hyperspectral imaging, X-ray fluorescence, IR reflectography, photogrammetry, and reflectance transformation imaging, among others, to capture these difficult to study objects and make them visible to scholars. But that is only one step on the path to true visibility for cultural heritage. Along the way, the object needs to be analyzed, papers need to be published, and then above all, the objects need to be made accessible to a general public in a way that is easy and compelling, that has rich metadata annotations to guide people through, and that accommodates multiple viewing modes in 2D and 3D. WEB3D is a platform that we're designing to answer to the need of visualizing, studying, and presenting these objects in a truly compelling way. But before I turn the presentation over to my colleagues, I want to give you a sense of the difficulties cultural heritage objects present. The image that you're taking a look at is, of course, Picasso's famous Man with the Blue Guitar, and we all know it as that. What we don't know, usually, is the pentimento that lies beneath it, which was imaged using IR reflectography. What we'd like to be able to do is be able to talk about both images simultaneously and to look at the very specific technical details of painting and of technological recovery that allow us to see two things in one. My next example is the Martellus map. The Martellus map is from about 1491, and it is a map that Columbus consulted before traveling to what ultimately was the New World. It's at Yale's Beinecke Library, and today it exists in a state that is, well, basically illegible. It looks like a large sand dune. Several years ago, the Lazarus Project imaged the map in tiles and image processed it very specifically. We imaged it multispectrally. And what the images that you're seeing are of one of those tiles, which is the lower right-hand frame, which describes what's in that map. And you can see the benefit of multispectral imaging. What the general public cannot do, and scholars couldn't do, is to look at the map under various bands and processing versions. to be able to transcribe the entire thing and talk about its relationship to other objects, like the Waldseemeler map, which is the first map to mention the word America. And this is another example of a complicated, difficult to study object, which Resurrect 3D addresses. So having given you these two examples, I'd like to turn the rest over to my colleagues. Thank you very much.
There are a range of existing 3D visualization platforms out there. Perhaps the most famous one is Sketchfab, and then there are also Voyager from Smithsonian and 3D Viewer from Zayak. With all these existing visualization platforms in mind, Resurrect 3D is not reinventing the wheel. Here are a set of principles that we had in mind that differentiate Resurrect 3D from existing systems. First of all, Resurrect 3D is a completely open source tool built from open source libraries. Researchers in institutions can essentially take our code and instantiate their own version to provide custom visualization services. And in that way, they can also control the data, which is of critical importance to the cultural heritage community. Resurrect 3D is also portable across different platforms, such as desktops, smartphones, and we have limited and ongoing support for AR and VR. And this is all due to the use of modern web technologies, which allows us to provide very similar user experience across different platforms. And so users don't have to refamiliarize themselves when porting to a different system, which is typically the case if the application was developed using native libraries. Resurrect 3D also is built with cultural heritage domains specifically in mind, which means we support a range of different data modalities unique or specifically used by cultural heritage domains, such as hyperspectral imaging. We also provide cultural heritage specific rendering and analysis tools, which we'll show you a little bit in a few slides. Finally, and perhaps the most importantly, we provide a set of flexible programming interfaces that allow expert users to design custom tools. And these tools could be either shading tools that allows users to visualize a model in a way that's different from the default shaders in 3JS, for instance. These tools could also be analysis tools, statistical analysis, and image processing tools to process a 3D model specific to cultural heritage artifacts. For instance, principal component analysis is typically used by experts to analyze hyperspectral image data. And that kind of tool is something that expert users can easily extend and integrate into Resurrect 3D through our programming interfaces, which I'll show you in a few slides. So now let me quickly go over the overview of the Resurrect 3D systems architecture. Resurrect 3D is built on top of the classic client-server architecture, where the server is built using Express.js on top of MongoDB, and the client side is built using React as the UI layer and 3JS as the rendering layer, with limited support for WebXR to support AR/VR interactions. What's really interesting in terms of the system architecture is how the server and the clients communicate with each other. For any initial communication between the client and the server, between a client and the server, is done through the REST API, which provides high bandwidth, which is necessary for downloading the initial model, which is typically of large size. Any subsequent communications, which are mostly initiated from interactions, they are communicated through WebSockets, which provide low latency communications. And one classic example is if the teacher wants to share the state, the current rendering state, to students. The rendering state is typically of small data size, such as a few measurement and annotations. And these small data are communicated through WebSockets using in real time. So this is how the basic UI looks like, where the left panel is a set of the annotation and cultural heritage tools that we'll talk about. And then the right panel is the main visualization window. Our development cycle is divided into two main phases. The first phase focuses on functionality, where the users would describe what they want to us without really specifying how the UI should look like. And then we quickly prototype a system and provide a demonstration to the users, who then iteratively refine the functionality with us. When the functionality is finalized, we then move into the second phase, where we focus on the UI. There, again, we quickly provide a prototype, and then the users help us continuously assess the effectiveness of the UI, including the ease of use and the responsiveness. And the second phase iterates until the UI is finalized.
I'm now going to walk through a few of the tools that our application offers users. Our platform supports a variety of material editing and relighting tools. Depending on the specific needs of the user, a plain model with standard shading may not be ideal for presentation, but with our tools, users can fine-tune the material properties and lighting to get the display exactly how they want it. Here's an example of relighting and material editing applied to a wax seal. The features that are barely discernible in the original model on the left become successively clearer as more tweaks are applied. Another feature our platform supports is eye-dome lighting, which is a shading method commonly employed in cultural heritage to clarify features or other points of interest. Here you can see an example of the method applied to a mesh of a graffito in an Italian villa. The feature of interest, which is scrawled into the surface, is barely visible with standard shading on the left, but becomes instantly recognizable when EDL is applied, as it is on the right. We also support user-added measurements and annotations, which can be used as scientific or presentation tools. The former, the measurements, allow scholars to document geometric properties of objects that are too fragile to be physically measured, while the annotations allow this information and anything else of interest to be saved in a persistent note that appears in world space on the model. You can see an example of that here with the Hunt Lennox globe. Here's a note of point of interest on the actual item. And these notes are implemented with a combination of React UI components and 3JS rendering, where screen space coordinates are projected to world space for calculations, then reprojected to screen space for dynamic user interaction as the camera navigates the screen. We also extend our markup options into a larger feature that we call storytelling. This allows multiple annotations, measurements, and material and lighting settings to be chained together in sort of a 3D PowerPoint. These stories can be saved for reproduction by another user, or presented seamlessly as a guided tour with a camera interpolation between points of interest, or even interrupted between actual points depending on the user's needs.
Now I'm going to talk a bit about the customizability of Resurrect 3D. This largely comes in two forms, the use of custom shaders and custom image analysis tools. So why expose functionality for creating custom shaders? Well, there's lots of creative shading techniques to reveal artifact details that have been developed in the cultural heritage imaging field. It's impossible and unnecessary to support all of these in one system. And these requirements may vary by users and developers. One solution that we propose is providing a programmable interface for developers to implement application-specific custom shaders. And behind the scenes, this leverages 3JS's capability of directly integrating GLSL shaders. So this allows developers to focus on shader design without worrying about how it's ultimately integrated into the bigger context of the application and how it shows up in the UI, as well as its interactions with the users. So we do provide some automatic UI integration for this. This is just a quick example of the programming interface that we've set up. So essentially, you write a function that takes a 3JS instance. We then return a promise, and the promise would allow for either asynchronous or synchronous code to be called. So the reason why we chose this pattern is because you can load, say, a vertex shader or a fragment shader from a CDN or a server, and you can also capture your uniforms in an asynchronous manner, but it can also be called in a synchronous fashion. So you get the best of both worlds. And this way we sort of abstract away a lot of the details. So how a custom shader is integrated into the UI, we actually have a set of registered components that users can call. As you can see on the right-hand side here, we have this add component method, which is setting up a range slider for users to be able to toggle intensity. You can also register a callback an on-change callback for that component. So that's called every time the slider changes. You can set min and max values. You can set the step value. So these are just simple GUI tools that essentially you just call this add component method, and they'll show up within the shader group here on the left-hand side of the React component. Users can also create and register custom UI components that aren't sort of within our sort of standard core library of components, but we have quite a few currently, such as a color picker, the range slider that we have here, toggle buttons, check boxes, radio buttons, that sort of thing. So this is just an example of a custom shader. So this is curtain view mode, which is a technique that is borrowed from multispectral imaging. So the way we've set this up is that users can upload multiple textures corresponding to the multispectral bands of an image. And so we can render variable number of spectra here. And then based on the integrated tools, the user can essentially change the sections that they're looking at, move the cursor around the object and reveal the different sections based on the multispectral textures. So why do we add custom analysis tools like the curtain view? Well, it enables pre-processing of artifacts for better visualization, and then eventually some post-processing for statistical image analysis. So the hope is that we can add some deep learning-based vision tasks. We do have generic programming interfaces for this, and developers are freed from UI integration. So this is just a really simple pre-processing programming interface for an analysis function. So again, you have a 3JS object or a 3JS group, and we're using the promise pattern. So you can do any sort of asynchronous programming and then resolve the finished 3JS object. So it's a very simple interface, and it allows you to do any sort of asynchronous programming that you want with the object. So in the case of curtain view, we are setting the different textures, the multispectral bands as different textures on the object. So some of the future work that we're planning on is supporting AR/VR platforms. So we've recently switched from WebVR to WebXR and are currently integrating that. And we're also looking into some richer storytelling capabilities through the annotation interface and beyond. And we're also open to the idea of enabling gamification of the platform in some way. But most importantly, we welcome contributions. So anyone that's interested can feel free to contribute. So thank you again for listening to our talk, and we look forward to hearing from you in the future.
Thank you to the authors for their nice talk. Okay, so do you have a question from our audience? Not at the moment. Perhaps in the middle time I have a question. Okay, so it's a very useful, powerful framework. And also, did you plan to extend this work, testing it with more user cases, or for example, extensive evaluation of the interface?
Oh yeah, I mean, the main thing we're working on is to integrate that into the to enable AR/VR experience, and we want to do this through web technologies, and so WebXR is sort of the platform that we're going to be building on top of. And I think there are a range of different reasons why we need to enable AR/VR technologies, and the main thing is because a lot of these cultural heritage artifacts are 3D by nature, and so you could use your mouse to scroll around, spin around, but it's not as intuitive as if you were to allow users to directly interact with it. So the WebXR interface is what we are primarily working on. So
that's clear. Thank you. And we have other question. Yes. Yeah.
Can I jump in? We have developed our own 3D viewers, or 3D, it's called 3D Op, and we spent a lot of time in making it extensible and enabling people to create different phases out of it. And then we realized that most of the user, in the end, they never used such intense customization. So most of the time, there is a different interface made using our tool. It was made by us. What's your experience? You experience the same kind of sometime disconnection between the group of final user and the group of programmers that are able to extend the tool?
Yeah, so we're definitely aware of your work, and we had the same sort of thinking, which is that there are really two types of users. One is the actual cultural heritage experts. They are not going to be doing any programming. They are just going to use whatever functionalities that you provide. And there, I think the customizability is really that we provide a range of different configurations, and they can configure things here and there by toggling switches and buttons. That's not what our extensibility interfaces or extensible interfaces are primarily targeting. What we're really targeting is those, developers. Like, so, there could be another institution who wants to instantiate or provide their own cultural heritage serving system, and they can, fork our repository and then develop on their own. But instead of developing from scratch, they can just use our program interface to extend it. And then, their end users are going to be using their instantiation of our repository. I guess, that's the sort of programmer developers type of users that our program interfaces are really targeting. But I agree that for cultural heritage experts that we work with, they are not really going to program in. They just use whatever functionalities are available. So
I'm glad that you encountered the same same issue. I mean, being considerate when you develop it and you make it customizable and modular, it's a great asset also for when you have to use it. Of course, it makes the things so much more clean and maintainable in the future. Of course, yeah. But I'm really glad that we are not alone in this with this issue. Thank you.
Yeah. Absolutely.
Well, if we don't have other questions, okay, we can go ahead. Thank you again to the speaker, to the authors. And then we can go ahead to the next paper. How long do you want to maintain this thing? Understand the challenges faced by WebXR creators. Speaker here is Inspire, researchers at University of Central Lancashire. And okay.
Hi everyone. Hi everyone, my name is Misbah Hozaber, and I'll be making a presentation on a paper that my colleague Nnamdi and I worked on, titled "How Long Do You Want to Maintain This Thing? Understanding the Challenges Faced by WebXR Creators." So I'm going to start by talking about what the WebXR device API is. So the WebXR API makes it possible for creators to access input and output capabilities of AR and VR devices. This can then be used to create web-based XR applications. So XR applications that can run on a web browser, whether it's on a mobile device or a headset or even on your desktop, as long as these devices have a WebXR supported browser. So this has a number of advantages both for creators as well as users. I'm going to stick to the advantages that the WebXR device API provides for creators, because that's what the focus of this work is on. So for creators, the WebXR allows the creation of cross-platform XR applications. So you create a single XR application that can be run on a mobile device or a headset. It also allows creators to use existing WebGL development tools. So things like libraries like 3JS, which have been used for several years for creating 3D programs on the web, can be used to create WebXR applications. And it also allows for the creation of future-proof XR applications, meaning that it is expected that future XR devices will come with WebXR support out of the box. And so theoretically, WebXR applications that are created now will be able to be used on future WebXR application, on future XR devices. And because these are applications that run on the browser, they can be shared easily using URLs. So creators can easily share their applications, and they can be accessed and shared easily by users. And then finally, WebXR applications can be experienced in either VR or AR with minimal code changes. So this study was conducted with the aim of understanding the experiences of WebXR creators. Now, similar studies have been conducted, and some focused on the experiences of specific XR application creators. For example, studies exist on that looked at the experience of AR creators. There are also studies that looked at the experiences of both AR and VR creators. However, none of these looked specifically at the experiences of WebXR creators or compared them with the experiences of native creators. So we conducted the study with a focus on WebXR as the XR development platform, and we considered the experiences of both AR and VR creators. We hope that our findings start a discussion on the situation of WebXR, it being a new development platform and all, and hopefully lead to discussions about how to resolve the challenges that we've uncovered. So the data collection for this study were conducted between May and June of 2021. We recruited participants through several social media platforms, specifically Twitter, Facebook, Reddit, and LinkedIn. And we looked for, individuals that have created WebXR applications or are currently creating WebXR applications. We used the WebXR hashtag on Twitter and LinkedIn to identify posts and then contact the authors of those posts and invite them to participate in the study. On Facebook and Reddit, we posted adverts to the study in the WebXR, WebVR, and the Immersive Web communities. We successfully recruited 11 participants to participate in the study, and these participants are from all over the world, as you can see in the table that, as you can see in the table that gives a brief profile of these participants. They use a variety of different tools to create AR and VR experiences, and the years that they have in terms of experience working with WebXR also varies. So in general, we have a diverse set of participants that took part in this study. So we used semi-structured interviews conducted with each one of these participants to collect data, and the interviews were transcribed and analyzed using thematic analysis to identify themes in the experiences reported by these participants. So 3 major themes were identified from our data analysis. So the first is the motivation for these creators to use WebXR rather than native, and then we found the challenges that these creators faced when they were using while using WebXR, and then finally we also identified the different approaches used by these creators to tackle cross-platform support for their WebXR applications. So in this in this paper, we mainly focus on reporting the challenges that our participants reported associated with creating WebXR applications. So the first challenge I'm going to talk about is the challenge associated with learning to use the WebXR device API. And this was a challenge faced by most of the participants of the study, including those that have spent several years working with WebXR. So the issue that was mostly reported was that there was a lack of learning resources for learning to use WebXR and the tools and frameworks for developing WebXR applications. And the resources that are available are not properly curated, which means in order for interested parties to find them, they have to conduct a thorough research on the internet. So this issue is associated with the second challenge we identified, which is the lack of awareness amongst developers and also users. So the WebXR developer community is a very small one, and that's because there is a lack of awareness surrounding WebXR device API. Even though there are several millions of JavaScript developers, because there's little awareness around WebXR, these JavaScript developers, even though they have the tools and experience that can allow them to create WebXR application, do not know of its existence, and so are not part of the WebXR developer community. And in addition to lack of awareness around developers, users are also not aware of what WebXR is, and that's also a challenge. That also creates a challenge for creators trying to explain what WebXR is to users and how accessible it is, how it differs to native, and how it can be used in contexts that are relevant to those users. There were also challenges that are associated with WebXR applications and their nature and the nature of browser-based applications in general. So the first is the performance limitations of browsers. So browsers are not as good as native. So browser-based applications are not going to be as fast, as performant. They're not going to do as much heavy lifting as native applications are going to do. And this leads to extra tasks that creators have to perform to ensure that their application is optimized. So these can be things like getting draw calls down, getting the material count down, managing number of items in a scene, which are all good practices that should be done anyways. But for WebXR application creators, these are tasks that must be done in order to make sure that an application is not, for example, very choppy. Then there is the issue of having different levels of support for the WebXR API on different browsers. There's a sort of fragmented support for the WebXR device API across browsers on different WebXR supported devices. And this creates a challenge because it makes the WebXR platform a very slow moving one, where at any given time there is no consistency in the support for the API amongst all current browsers. And this means that it's difficult to create state-of-the-art XR experiences that work on every device's browser. This then makes WebXR creators to sort of play it safe and go for features that they know are going to work on every device's browser, even if that's not going to create the most or the best experience for their users. And then finally, there's the issue associated with keeping up with updates. So the web is an ever-evolving platform. So there are always going to be updates for browsers, development tools, development frameworks, and even the WebXR API itself can be updated. It is going to be updated, and this can break WebXR applications or expose them to security threats. This means that when you're working on a WebXR project, you can never truly finish working on that project. You're basically on a journey that depends on how long you want to keep maintaining the project. Lastly, we have a set of challenges that were reported by users when discussing the cross-platform support offered by WebXR. The first is the challenge caused by differences in hardware and software across WebXR supported devices. So although WebXR application can run on all WebXR supported devices, the experience of users may vary depending on the device the users are using. This makes it hard for creators to create consistent experiences for users regardless of their devices. Another challenge associated with cross-platform support is lack of iOS support for WebXR. At the moment, Apple's Safari web browser does not support WebXR, and according to the creators that participated in our study, this is a barrier to mainstream acceptance and complete cross-platform support. Lastly, there is the challenge associated with testing. So the first challenge associated with testing WebXR applications is that there are a large number of WebXR supported devices, and access to these devices can be difficult. And even when there is access to these devices, small teams or lone developers may not have the resources needed in order to test their application on all WebXR supported devices. There's also the difficulty, the tediousness, the discomfort associated with the iterative process of testing applications on a device such as a headset and then tweaking your code or making changes on a desktop. This continuous iterative process can be very slow, uncomfortable, and challenging. So with all that said, we believe that moving forward, there are several things that need to be done in order to move WebXR forward. First of all, there needs to be learning resources for WebXR and its development tools need to be developed and, more importantly, curated so that they can be easily accessed by interested creators. And then there needs to be a move towards developing and sharing guidelines for creating and maintaining consistent WebXR applications. There needs to be development of tools and guidelines for testing WebXR applications for all WebXR devices. And we also think we believe it is very important that WebXR is not considered as a competing platform to native, but rather as a complementing platform. We also believe there should be a drive towards promoting awareness amongst developer groups, including the more than 12 million JavaScript developers worldwide. There should also be a drive towards promoting awareness around WebXR amongst users, and also a move towards identifying ideal use cases for WebXR applications. This can truly help in seeing WebXR as a complementing platform to native if we can figure out the ideal use cases where WebXR is a more fitting platform than native. And then finally, we believe that it is very important that moving forward, WebXR is advertised with full transparency.
for the presentation.
Okay, yes. Okay, and find the. Okay.
I want to say something about to the spectators. So more than a question to the authors was something to promote discussion. Also, the reviewer that judged this paper found that it struck home on many considerations about WebXR. So as developers, that they found the same, they found that their own issue described in this paper. During the conference in these days, we had different talks about WebXR that seems to become the new, the ideal standard for some platform, especially this meta stuff that is becoming the next buzzword of this conference, and not only of this conference, I fear. And so I believe this work can be a good starting point for a discussion in the community and also for the people now connected about the state of WebXR. So Neil Trivet, the first day, showed how OpenXR has become standard on most of the hardware platform and software platform. So this hopefully should solve at least some of the issue that were mentioned in this paper. But it was clear also from his interesting presentation the first day, you can find the record on the website, blah, 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 that we are still ongoing in this process. So probably, as the author said, the community has to step up at the moment and provide better example, better tutorial, better to come out filling the gap of the WebXR experience at the moment, since it's becoming so important. So thank you again to the authors. Just wanted to point out this thing for the entire audience.
Somebody have a question? Otherwise, I have a question too. I am not sorry, I'm not a user of WebXR, but I could. So I was just interested about spherical and equirectangular images. Does they are support by WebXR? The equirectangular and spherical projection as a stereoscopic view or even a monoscopic view of spherical images or equirectangular images.
Sorry, you went off for a bit. I didn't catch the question. Could you repeat it? Sorry.
Yes, I was just asking if equirectangular images or spherical panoramic images are well supported in WebXR or how are supported.
Oh yeah, I mean, so for example, A-Frame, one of the most popular frameworks for developing WebXR applications, you could easily use that to add images. So you could add them as just a single images. You could add them. I think there are things called primitives that you could use to add images, so that you can create things like a skybox. So there are primitives for those sort of things. So A-Frame, yeah, it is a very good tool that you can use for those sort of things. So and easily add it to.
Okay, thank you. Yeah. Okay, if you have other questions from the auditors, no? Audience, chat. We don't. Okay, thank you again to the speaker and the authors for the nice talk and for the discussion. We don't have other points to discuss. I think this session is going to close. I see. Okay. As the organizers say, okay, discussion can continue on the application. Okay, and for the chat and the speaker. Okay. So I'm going to close the session. Thank you to the speakers and authors and also the organizer to invite me to this session. Thank you again. And okay, see you for the closure session. So
thank you to anyone that participated. Thanks to the chair. And we will have some a bit of a pause because the next session is at 5. Be there because there are the best paper awards, there are the showcase by the audience, and the closure session, all the things that you normally find in a closure session will be there. So thanks everyone, and let's see you in 3/4 of hour at 5 in this same chat. Bye.
I was trying to show my 3D in a cool HTML. Turned out was not that easy. It didn't work so well. So I tried browsing around. For an answer took so long, till I found this orange website where I heard singing this song. WEB3D is the place to be. Here your scene will not freeze, it will show like a breeze. You'll see WEB3D, you can join for free. Thanks Chronos and Ivy, and you can log in and then leave. WEB3D is in Italy, with the sole and the mare, the best of mangiare virtually. Don't be mad, don't cry and be sad. You will follow our rants, dress code underpants. Now picture that at WEB3D. It's so fun to be, and the social event takes your tower that's bent. You see WEB3D is in Italy. I hope you enjoy. Good luck and then fun virtually.
Hello everyone, we are about to start. Just a couple more minutes to have people coming in and move from audience to members and so on, and we'll be ready to begin. Just a couple of minutes. Hey, we are at the end. Welcome everyone to the closing session. So let's start this session. And first of all, thank you for keeping up with us and being here for the entire conference, for participating in discussion, for waiting for the time to come and waiting for us to start the session, waiting for everybody to be ready. And so thank you, because we really wanted this conference and this event to come out well, and thank you to all the participation that you gave us. So let's start with the first thing, that is the Flash showcase. So in the opening, we asked the attendee if they had something to present, and we asked them to send a proposal. And we got 3 interesting submissions, and now we will give the podium to them, and they will have 3-5 minutes to show their work. So the first Flash showcase is Edward Silverton, exhibit.so, storytelling with IIF. Then we will have Emmanuel Vokaitis, a Vim-like voxel animation editor, voxelpocopy.co. And then we have Luca Brunk, Florence 4D, documenting and disseminating a Florentine church in 3D. I will now give the floor to the first presenter of this session. So Edward is already one of the panelists. You can share your screen and present your work to the audience.
Hello, is that coming through okay? You see my screen?
Yes.
Great. So yeah, I'm Ed Silverton. I work at a company called Nemoscene, based in Brighton in the UK. We work primarily with cultural heritage organisations to produce engaging experiences using their digital collections. Here's an example. Here's our website. Some examples of our work. We make sort of AR apps. We work with the Science Museum to do photogrammetry, modelling. We worked with Royal Pavilion Museums recently on their digital catalogue, which contains some 3D aspects, and immersive things, etc. So I've been lead developer of the Universal Viewer project since 2013. This is an open source viewer for cultural heritage content, which uses the IIIF specifications. IIIF stands for International Image Interoperability Framework. Bit of a mouthful, but I'm co-chair of their 3D working group. So yeah, anyone interested in joining that, it'd be lovely to hear from you. So yeah, this is a kind of a project I've been working on for a while, but I'm here to talk about this, which is exhibit.so. This is a project that incorporates the Universal Viewer, and it was for, we made this for the University of St Andrews during the COVID-19 lockdown, so that their students could use IIIF content within their St Andrews digital catalogue to tell stories and submit as coursework. So the catalogue contains high resolution images in IIIF format from their library, but also 3D models in GLTF format from their museum. So they wanted a tool that could combine all of this data so the students could create compelling stories with it. So we have some examples here. There's a gallery here. If I open this one, it's the standard kind of format where it's kind of a slideshow format. So as I click through, it's going to zoom in on aspects of these images or 3D models we'll come to. Zip through, try and get to a 3D model. So this is using, this is Jane Austen's writing desk. And this is using Google's model viewer under the hood. So you can click on, there's two buttons here. You can create an exhibit from a demo, which is this Jane Austen one, or you can create one from scratch. What could be quite good is, and this is a useful feature for lecturers at St Andrews, where they create an exhibit and then they ask the students to click the duplicate button so that they don't have to kind of fill out their own exhibits from scratch. So if you click duplicate, you can turn duplication on and off as well if you don't want it. Create an exhibit using the Jane Austen one as a template. And here we've got the universal viewer. We can page through this. We've got sort of annotations here on the left. We can kind of reorder these, click on them, edit them. So if I were to add another annotation, I could zoom in on this signature here, write comments, add that, and that would become part of my story. I can also switch to scrolly telling mode using this toggle button down here. I'll click preview. And this is actually becoming a more popular format, I think, for exhibit users, where you just scroll. There's no clicking involved. Yeah, and I'll demonstrate adding an item as well. So if we go here, you can see that each of these have already been added, but if we click on the copy button now, we can see the IIIF manifest that's being used. So if I select the Jane Austen desk and add that, this is coming from the British Library's 3D collection. And then zoom in on this and add a couple of comments. And then those get added to my story as well. So that's pretty much it. I'm on Twitter, on edsilv, EDSILV on Twitter, and you can reach me there if you have any questions about it or would like to get in touch. Thank you.
Thank you very much. And we should have here the second presenter, Emmanuel Vukaitis. He was here before, then I see him disappear and then appear again. So let's see if it's if he's available. Emmanuel, if you want to share your screen and show your project. It's a project that I like very much. It's an interesting little piece of tool.
Apologies, if anybody can hear me, I'm not really ready to share my screen, unfortunately.
Okay, I can maybe share the. Oh, you may talk over the application. That is this one. In the browser voxel editor animation. unfortunately, I'm terrible at this kind of art, so I try to use it, and yeah, it's simple to create new voxel and frame, but the animation that I try to create, you won't like it because it's really terrible. So I'll show the default animation. This was the submission of Emmanuel Vokaitis, and it's really, really, really cute. We can create animation step by step to test it, and by using all these integrated commands. Pretty nice. Okay. And so we may go to the third and last contributor to this session, which is Luca Brunke. Luca, are you here?
Yeah, I'm here. Hello. Okay, hello, I'm Luca and I'm part of the WEB3D team, which is based at the University of Exeter and Cambridge. And I shortly want to show you what we are doing and on the website we are currently working. WEB3D is a project that adopts digital and art history approaches to deliver a shift in context-based research on art and architecture that can be delivered through the integration of spatial methodologies, especially mapping and 3D. The project itself focuses on Florence and on artworks which are based in museums here in the UK. Like previous presentations, we are also using OmikaS to store the research data and IIIF to deliver it to our web application. Here you can see work in progress of our current website. And what we have is here a map, and all of the data points are stored as data sets in Omika and delivered via IIIF, and we have small 3D models, which indicates where we have more data to present and show. Instead of using the normal map functionality, you can also search each of those data points and the content behind it. Or like any other web map, you can do basic operations like panning, zooming, rotating, or layering different, layering historic base maps above each other. And what we also have, we have tours. Those are curated data sets, and those tours can also contain access to our 3D models or 3D reconstructions of the three churches I saw earlier. Here, this is, for example, the Innocenti Church. And at some points, you see those little tooltips, and they indicate a link to our research database, which also allows you to jump into time to visit different time phases, and also to see additional content and additional informations to all of those artworks which were scanned. And yeah, they also give you the possibility to get back to our research database, which gives information about our sources we used and how we recreated them. Yeah. That's what we have been doing, and we expect to launch the website in early next year.
Thank you very much.
Yeah. Oh, okay. Thank you.
No, you want to add something? Yeah, please.
Yeah. Oh, yeah. We also expect to add other models or all our 3D data, but it's currently more work in progress. Yeah.
For the authors, if you want to post your link in even in the WAP or in the chat for the audience to take down the address and contact you later if they are interested, or if we have some question from the audience, we can do it too. It's up to the current audience. I don't see any here. Except some very cool, very cool, very cool. Everyone is happy about what you have shown. So yeah, they use the chat here or the Vuva app to send your contacts, and so people that are interested can contact you.
Yeah,
thank you so much for presenting in this flash session, and so we can now go onwards with your words. Fabio? You're still muted or the microphone is off.
Can you hear me?
I'm sorry, do you mean the H&M session now?
Yes.
Can you hear me?
Yes, we can. I wanted Fabio to start with the award that yes is the award session. Start with the H&M, yes?
Oh, yes. So may I share my screen now?
Yes, please, go on.
Okay. Okay. Welcome to the H&M Awards 2021. My name is Myung-won Lee. I'm the H&M Working Group co-chair. We presented the summary of H&M competition on the second day. Today we announced the winners of the 2021 H&M competition. I will skip some slides of these slides because I already explained them on the second day. So I'll move to the slide, the next slide for 2021 winners. So now we'll have a look at the submissions for 2021 along with the judges' result. These are the evaluation results for the 4 submissions. We had 4 judges. Do you see my another screen? For example, do you see my chatting? No.
See the judges and the scoring. Judges' results.
So I'm wondering that you if you see my the participant pane. So because it is now over the presentation slides. I don't know why. So next I show you just a moment. Okay. So this year's examiners are as shown here, all are HRNIM experts and HRNIM working group members. First prize is awarded to Eun-gyu Lee. We will see the video shortly. And second prize is awarded to Gyuri Cho. Now to the summary and the scenario for each video. This is the scenario of Eun-gyu Lee's animation. His animation is about hip hop animal. And next, this is the scenario of Gyuri Cho's animation. Now we will see the animation videos of two winners. First is animation by Eun-gyu Lee, entitled Hip Hop Anywhere.
You should have shared also the sound. If you want, I have the two videos here.
Yes, I'm sorry. Just a moment. Can you hear the sound?
Yes.
Okay, next is by Gyuri Cho, and its title is A Day of a Country Girl. This is a list of all the entrants this year. Thank you very much to everyone for their submissions. Please contact HN Working Group and WEB3D Consortium if you have any questions or need more information. Thank you very much and see you at next year's competition. Thank you.
So thanks, Professor Myung. And now we had for this conference two awards. One for the best paper of the main track and the other for the best paper of the cultural heritage track. The decision, especially for the main track, was taken today because we had the last session this morning. So we were also preparing the certificate and everything related to this award.
I got it, Marco. You don't need to buy time anymore. Thanks.
We can switch to.
That's our way. Okay. There was some last minute mishap. Let's show this slideshow. Okay. Okay, so let's start the best paper ceremony. It'll be fast. Okay. As Marco was saying, it was a tough decision, but also because the last session of paper was just 1 hour ago. And the name you see, it's mostly us, the committee. We couldn't include people with many papers. And the criteria are the usual one. So it's partly on the review scores, and a good part, I would say, in the presentation. So the presentation plays an important role. I didn't write it down, but presentation and question and answer, they are all part of the prize for the best paper. So not just the paper, but also how the paper is brought to the conference. So how it is disseminated, how it's explained to people. And the winner is the paper. Yes, I got it wrong. Sorry. There we go. I switched them at the last second, and we are right. The paper is a platform for developing and fine-tuning inclusive 3D navigation techniques for the immersive web by Ahmed Kamal and Carlos Andujar. And so congratulations, Carlos. I believe you are also here somewhere. There you are. So Carlos, congratulations. I don't give it to this physically now, but it's your certificate.
Thanks a lot. Also on behalf of my co-author, Ahmed Kamal. Thanks a lot.
So good. And now you already had a sneak peek of the other one. And for the online legacy and cultural heritage track, the committee were the organizer. So Martina Verolami, Lois Offenhagen, sorry, that's her name, and Nicolo Dell'Unto. And for that track, the award goes to, again, since I switched, to Laura Harrison, Rosemary Damour, Howard Kaplan, Christopher Hubbard, and Eric Santiago for their paper, Augmented Reality for Digital Placemaking, Public Art in Clearwater, Florida. So congratulations to you as well. And I think
so much.
You're welcome. Thank you for submitting. Okay, and I think the next thing will be the closure. So since I'm here, I will go with the closure. So I'll breathe a little bit. Sorry, for my colleague, I stay with the mask when I'm not talking, and I take down the mask where I am talking. So it's been a long ride. It started now a couple of years ago, actually. So half a year was lost because of the COVID and the displacement of the previous edition, but still it's 2 years. I was going through my email, and just the emails with Web3D on the subject, which are a part of the email, are 514. And we had this 38 Zoom meetings and as many Skype meetings, and they were just coordination. that means that there is other job to do, not just send an email. So for the next one, there is work to do. Just that, okay, just that you know it. And now with the Isola thanking for our people, as I named this Stamina Heroes, Marco Callieri, I don't think I need to explain how I already thanked the people at the beginning of the conference. So now it's for these days. And Marco Callieri basically hosted the whole conference, and he covered all the roles. As a few minutes ago, also the author's role. So it was also Southern authors. And Marco Potenziani, you haven't seen him much in the video, but it was the conference backend all along. So here we have the limit. We know that with 2 people like this, you can go and do the next edition of WEB3D. So, and then there was me, who's basically, I was just basically a backup, having fun with the social event, the song, all this stuff. And when I say trolling people on Whova, it's because we actually risked to lose a submission, because when I saw Florence 4D, I replied, sorry, Luca, the conference is only for 3D stuff. Too bad. But then it was confused, but then we get a submission. So that's to clarify my role. And we cannot not mention Don. Don is in another time zone, and I think another planet as well. He was always present, tweeting, making questions, animating. He's really a piece of work. It's really incredible. And then Anita, all this year, was super reliable all the time, super knowing all what to do, the right people, who should I ask for, this stuff or this other stuff, up to today, okay? And Carol McDonald as well, very, very present in the whole session. Also for her, very difficult. They are all from US, so it was very difficult. Never shown in video though, so that's why I placed that. That's what I have. And of course, again, all the people from our organization, for the special track, the chairs, the steering committee, which are again the same people again, and for the annual competition, and the international program committee that were quite a lot. They worked. And then we made this possible. And of course, the sponsor, the support that we have from the Web3D consortium, the cooperation we have from SIGGRAPH, and the money we have from Kronos, is a gold sponsor, and from Integrated Virtual Network, which is a silver sponsor. And I also say for the last time, you can hear the music because I'm not sharing with the music, but I mean, thank you for the music to an anonymous group of ensemble of people who put together the song. And how to say, in Cauda Venom, the poison in the tail, we this year tried to do several things. As you saw, a special track on online legacy and cultural heritage, which worked beautifully. But also there was a special track on digital fashion in the web, for which we had a committee of academic, known people, people from the industry who tried, and yet we didn't manage to get interest from the environment of the digital fashion. And still there is a lot of ground in common. So that is something that we tried hard, but it just didn't work out. And the same goes for the competition, make a 3D logo for the conference this year. There were money in it. It was a simple thing, but probably we didn't have the right place where to disseminate this. We try a lot and we had no response actually. So, you know, you should learn to embrace your success as well as your failure with, you know, I would say, quiet, dignity, and grace. And some final consideration, the reason we did this was to broaden to the audience of Web3D, to have more subscription, to the registration to the conference, to have more submission, but also just because Web3D, what it looks like is not more a niche thing or some specific group doing something that the other don't know. Now is the world. 3D and web is not something, is something that should be broader now. And it's also because it's nice when there is a great environment here. It's a great consortium, and it's nice to feel home when you go to a conference. It's nice to meet people that you already know and feel at ease. And this is very, very tangible here, even virtually. But we should also be vigilant that the home doesn't become the conference itself. Otherwise, that's is the path to be more self-absorbed in a way, self-referential, and in the long run, less relevant. So, with this last remark, who's up for WEB3D 2022? The best of luck, and we are out. And I leave the floor to, I believe, Nicholas or Don. Guys?
I'll lead
I
off.
just promoted
thank you,
Nicholas.
thank you, grazie.
Oh.
Nicholas is here. Okay.
All right, there he is. Grazie, grazie, grazie. Bravo. You guys were awesome. I don't know who's 2022, but what a tough act to follow. And that's a good thing. So a million thanks to all of you. Just totally impressive.
Yeah. Wonderful work. Congratulations. Yes, bravi. Thank you so much. I think you guys have set a great new standard, really, for, I think the conference was really enjoyable and effective, and sets us up for a great trajectory for the next 25 years, right? So I really thank you again. Yeah. So I thank you again. And of course, the steering committee, I should also mention Dieter Fellner and Neil Trevitt are also our constant consultants on that committee as well. So thank you again. And we'll look forward to working with you all this year and on top of the great groundwork that we've laid here this week. It looks like Anita is maybe trying to share a great dialogue this week with SIGGRAPH and some of our colleagues from different communities. And the time is now to sort of start to plan and see if we can make some of those ideas real over the next year. And so certainly the Web3D Consortium, as a not-for-profit member-driven organization, welcomes everyone to join us there in terms of having a process and infrastructure, and again, a welcoming environment for this work to take place. So please join web3d.org, and we'll continue these conversations. I think that's all I have. Anita, there we go. Wonderful.
Hello, everyone. Can you guys hear me?
Okay.
Can you guys hear me?
Yes.
Yes.
Again, I would like to really thank our hosts. Bravo. Thank you, Fabio, for leading this team. Thank you to our program chairs. Also, thank you to all our authors for submitting some amazing content, and congratulations to our winners. Even though we know that the virtual conferences are tangible, I'm trying to make I guess you guys can't hear me. Is this better? Even though we know that virtual conferences are tangible, I think it's time for us to meet in person. Networking is also important. So we are hoping that we will see you guys either in Europe or maybe Vancouver next year if we co-locate with SIGGRAPH, and probably Asia in 2023. So we look forward to seeing you all. Congratulations to everyone, and we see you next year.
Don, are you saying something? Because I hear some background. Anyone?
I believe it's over.
Yeah.
No, there's a question from Carol.
Looks like we don't want to leave this platform.
No,
we
I thought
paid. We already paid for it.
We've said bye and thank you so many times.
Go home. Oh, we are home.
Okay, so thanks everyone for coming here. We were really happy to host you, even just virtually. We really tried hard to make it physical, but unfortunately it was not possible. In the end, I still believe we have done something nice. The conference came out well. We had participation. We had very good contribution. So I love how the different papers and the different tutorials and workshop came out, and I believe it's successful. Now, the platform VUVA will be alive for, I don't know how much, because I simply don't remember how much time after the end of the conference the different board will be up, but the discussion on the papers and question and answer may continue there, as well as messaging between attendees. We are moving all the content of the conference, so the videos, the papers, and everything on the website. So soon you will find all the video of the session, and most of the videos of the pre-recorded video of the presentation are already available on the website and will be available also on YouTube on the channel of the conference. We'll probably send next week a recap email containing links to all the resources that you can go and enjoy to get back to the session that you could not attend because they were at an insane hour for you. And yeah, Martina was raising her hand.
Yes, hi everyone. I'm so sorry for being so late. I got stuck in the traffic. I'm sorry, I'm in Rome, and that's a variable that you can never actually anticipate. So I'm very sorry not having been able to join for the award. But I just wanted to thank you all once again. I guess you already awarded Laura Harrison for our session. So I'm sure everything has been dealt as it should be, but just thank you very much, everyone. It has been a great marathon, I have to say, but we really enjoyed it. So thank you.
Thank you, Martina, and the Cultural Heritage team that assembled a nice lineup of paper and showcase a different side of the use of Web3D. As Fabio said, there are many communities that use Web3D, and they are not always the contributor to the main technology behind it, but they can provide good insight and different perspective also on the social implication of the presence of 3D on the web, and probably it's a trend that should continue also in the next conference as an idea to have a focused session on specific topic. So again, returning to the resources, we will make everything available as soon as possible. We are moving videos in and out from YouTube, the archive that we used in these days to manage the session. So it's not over yet. I mean, there's still content that you can browse and appreciate, even if these 5 days has finished. So thank you again to everyone, and if no one else want to take the stage and say something, we can just send our song another time.
One last thing I would like to
Please.
add is the publications are available for another 30 days. As you can see, the community is engaging with us. I mean, this is the research part of the conference, but here it's free for download for another 30 days. Please do so.
Absolutely. It's a great resource for all the people that are working in this field.
Yeah, and it's not just free for 30 days, it's open all the time. So you can become a member. You are allowed to become a member of CM SIGGRAPH. And you're also, if you work at a university, you're allowed to say, hey, fix our connection. I want this every day. I want this every night. Remember, yet another way to shoot and keep going.
Thank you very much again, and see you next year, somewhere. Goodbye.
Goodbye.
I was trying to show my 3D in a cool HTML. Turned out was not that easy. It didn't work so well. So I tried browsing around for an answer. Took so long till I found this orange website where I heard singing this song. Web3D is the place to be. Here your scene will not freeze, it will show like a breeze you see. Web3D, you can join for free. Thanks Chronos and Ivy, and you can log in and then leave. Web3D is in Italy, with the sole and the mare, the best of mangiare virtually. Don't be mad, coat underpants. Now picture that at WEB3D. It's so fun to be. And the social event takes you a tower that's bent, you see. WEB3D is in Italy.